Okay, thanks everyone for joining this session. So we will talk about the infrastructure of DockerHub. It's not to make great infrastructure or how to do this thing. It's just to give you some ideas, to show you how we are doing it. And don't hesitate if you got questions, remarks, or better solution to all of that. So I'm Romain, I'm part of the infrastructure team. Normally, Jael should be there, but it couldn't make it. Yeah, sorry about that. So we'll be alone to present that. Normally, I know all the details, but prepare not everything. So first, we'll talk about the component of the infrastructure, because Docker is not only the Docker daemon, but we got other things. So first, we got dockerhub and Docker Registry. So on Docker Registry, you can send your Docker image or all you can image. So Docker images, OCI images, do pull, push, tags, etc. And on Docker hubs, you will manage these images, also your accounts, your organization, and also all the billing parts. So if you got some different plan, because yeah, if you want private repo and etc. And lastly, we got some SSO. So if you want to authenticate with your enterprise authentication system, it's also possible. And lastly, we also host all the Docker releases. So that means Docker Desktop, Docker Daemon, Compose, CLI, Containerd also, and all the desktop extensions, the plugin, etc. And some websites, so the docs of Docker, so don't hesitate if you got question or you need advice going to the docs, and all the websites, so docker.com and dockercon.com. We got also some parts that you saw on the keynote, so regarding Scott and all these big things, but yeah, not showing there because it was not still released. For all of that, we got some caching in place, so using different CDNs, so content delivery network. It allows us to make it available worldwide, so in different regions. We got Cloudflare for all the registry traffic, so when you pull images. And we got CloudFront, so Amazon solution for all our releases, and also the static files. Yeah, I forgot to a big number. It's some number for Cloudflare. So we got 130 petabytes served per month by Cloudflare. It's something that they're telling us with an image. It's quite nice, scary maybe, and for more than 99% cache. So that's only pulling image traffic. That's, yeah, that's what we got. And we got also some dynamic content, so for all our website and all, going to making requests to our databases. So all of that is behind our application load balancer. And we got an average of 50,000 requests per second, so Scots. But 30,000, but it's more 50,000. I think it was not up to date. And it's all for, yeah, like I said, it's all for our databases and things like that when you want to make change on DockerHub or with Docker commands. And for the number, it's less accurate than Cloudflare because it's from our internal metrics on Prometheus, making so query, things like that. But it's around 2 petabytes per month we are saving with this application load balancer. So let's talk about our infrastructure, how it's made. So it's a part I didn't, yeah, reassure because it was a Jeff part, but that would be fine. I know about it. So it's our infrastructure. So it's deployed on Amazon. We're mostly on Amazon. Yeah. So everything is set inside one region, and we are using the CDN to make it available on all the region. So we got, yeah, like you can see, we got some public load balancer, but we got the application load balancer inside some Kubernetes cluster and our application. The application can access some content databases and things, and on the left side, you will have all the CDN things or to access static files. All these things are on multiple availability zones, so that's different zones inside Amazon. So normally, if there's an issue in the zone, you've got no issue, but yeah, it's Amazon stuff. And yeah, multiple is the same, multiple AWS account, multiple EKS cluster, multiple environment. The thing is to have multiple things, and like that, you got less issues. So something also to show you is inside this infrastructure, how some basic calls to Docker registry are made. So is that something first when you are doing, it's an example with a Docker pool. When you are doing a Docker pool, you need first to authenticate to a registry. Even if you don't have any account, etc., you need to authenticate to it. So first, when making the command, so I will try to describe all the different calls. It's also something available inside our documentation. Don't hesitate. A lot of things are inside our documentation, and yeah, and it should be the same behavior for ECR and ACR, so other registry except Docker. So yeah, the first call, so in a way it will call registry, try to make a pool. Registry will answer, you not authenticate, so after it will generate some token with the authorization service that will come back to your Docker daemon, and after that it will call again to registry to check if you are authenticated with this token. And with this token, we can know if you are a user, your plan, and all of that. After that, other calls are made. And you see here, you will have some, we will talk also to Cloudflare. So like you can see, it will go first, yeah, it will go directly to registry, and registry will give you some signed URL. Because registry will check from which region you are. If it's inside US East 1, so spoiler alert, the region we are mostly, and a lot of people on the internet are inside this region. If you are inside US East 1, you will go directly to S3 and grab the images. If you are outside US East 1, you will go to Cloudflare. And on Cloudflare side, we are using Cloudflare workers, so it will check if your image is on the cache. If it's not on the cache, it will directly call S3 and put it on the cache. So that's why when you can be anywhere in the world, you will have quick answer from Docker registry. Normally I said everything, yeah. So now let's talk about EKS. So we got multiple Kubernetes cluster, and we are using Amazon EKS, so Elastic Kubernetes Service. So we are using EKS because we don't want to manage the control plane. It's not something you want to manage. And it's quite cheap on Amazon, and I think it's the same on Google and Azure. It's quite cheap to have a managed one and don't care about it except do an upgrade. We are using EKS add-on for that, so for all the standard components, so kubectl, core DNS. We deployed core DNS on Fargate, like that it's not on Node, and it won't be impacted by Node scaling. Core DNS also scale depending on the number of nodes of the cluster. It's something recommended by Kubernetes, or try to do that. And we got after on as EKS add-on the two container interface, so the VPC CNI, container network interface. It will allow to assign one IP per pod of your subnet. And also the CSI, EBS CSI, so container storage interface. So it will create an EBS volume, so that's the block storage of Amazon every time you create a volume on your Kubernetes. And we got also other things that are not CKS add-on, but you need it if you got, I would say, a Kubernetes cluster or an EKS cluster. We got the EMM or IDC providers that allow for a pod to access some cloud resources on your AWS account. So it will match here. You will need to create a service account. The service account will be linked with your AWS role. And thanks to that, you will have the access you need from your pod without sharing any credential, because you don't want to share anything like that. We are using SSM secrets. So SSM, that's the old name of Amazon. Now it's a System Manager Parameter Store. We're using that because it's cheaper than Amazon secrets. I mean, yeah. And we're syncing the secret with external secrets. So same, if we want an application, so inside the container to access the secret, we'll configure external secret to create a Kubernetes secret that is the same as the SSM secret. And for things we don't, not user-facing, so non-critical access. So for example, hub.docker.com is not configured like that. So we are using AWS Load Balancer Controller and external DNS. So that's allowed to open the access to some applications, some pods, directly from the outside. So you will create a Kubernetes service or a Kubernetes ingress, and it will create directly a domain name and a load balancer. So you will have a domain that will link to a load balancer, and after it will go straight to your pod. But yeah, it's not something we prefer to separate that from some Kubernetes control solution, because yeah, we prefer to know what it's doing. So now let's talk about pod scaling. We are using something called Carpenter. It's not a Carpenter presentation, so if you want more information, go to carpenter.sh. There are a lot of documentation there. It's a replacement of Cluster Autoscaler. It's built by Amazon and currently only using on Amazon. Maybe at some point they will use it on Azure or Google, but for now, not possible. What is good with Carpenter is it's not using node groups, and it's closer to your resource request. So it will always try for you to use less nodes and cost you less money. So for that, I will explain how it's done with Cluster Autoscaler, so what we were doing previously. So first, with Cluster Autoscaler, you need to create node groups. And these node groups can be created inside Kubernetes. So you need to manage them outside Kubernetes. And it's a pain. It's not something that you want. And also, one node group equal one instance type, so a type of server. If you need a different type of server, you need to create a different node group, manage them, etc., etc. So yeah, it's working the same way for Carpenter. So you got a pending pod. Cluster Autoscaler will say that this pod can't run on the node, so this node is already available, so it will create a new node. But this new node will be the same instance type, C5. Here it's C5 X large, but it's how it is done. It will create a new node and run your pod on it. What could happen with Cluster Autoscalers is that you got some nodes that underuse, because here on this node there's not a lot of CPU and memory available. Maybe here there was some availability, but not enough for this pod, and yeah, it's not really optimized. And also, with Cluster Autoscaler, your node image will be out of date, or you need to manage them, like the node group. So you need to manage the image, do the upgrade, etc. It's a pain. And it's something that we didn't want to do, especially when you got a lot of cluster. So with Carpenter, it's quite similar, so except that you don't have any node group. So you don't have to manage the node group outside of that. And what you will do is that Carpenter will check your request for this pod and will say, okay, what is best for this pod is this this instance. So for example, we got a big instance there, and he said, okay, it's best to run it on this instance. So it will create an instance for that, attach it to your cluster, and run your pod on it. What is good is that your nodes are optimized. You don't have a node that's not yours, that got some resource not yours, etc. And also, Carpenter can do some consolidation. So if at some point these two nodes, Carpenter will see I can run it on only one node. It will spawn a new node that is optimized for that, remove this one, and you will have only one node. And also maybe gain some money, because that's also one goal of Carpenter. So something we are doing, it's possible to run, because you need to run Carpenter somewhere. When you spawn your cluster, you got no nodes, but you need to run Carpenter. Maybe at some point, Amazon will allow to run it as a EKS add-on, I don't know. So if you want to run Carpenter, you can create a node group, but you don't want to manage a node group. And it's like the egg chicken issue. How can I run Carpenter? So what we are doing is running it in Fargate. Amazon got that. And it's running quite well. It's what we got also in production. And no issue there. And the two big features of Carpenter and why we went to it is that it will always run the latest EKS image. When you spawn a new node, it will check the latest image available, and it will run it. It will run the node with it. And something else that you can have time to live on your node. So you can say, my node, I want it to live only for 7 days or 30 days, something like that. So after 30 days, the node will be recycled. And because it's recycled, a new one will be spawned. It will have the latest image, and you can upgrade your node like that. So that's why we went for that. We wanted to have the latest security fix, latest security patch on our cluster, and not to manage all the upgrades of the nodes that are quite painful. So like that, it's done in a way automatically. And it's running well, no issues there on our cluster. So for that, Carpenter is using two Kubernetes resources. It's always done with Kubernetes. So the first one is called a provisioner. So here's the default one. You need a default one for everything. So like that, all your pod will use this configuration. So what you can do, you can specify an instance that you want by default. Or maybe you want only one instance, but that's our stage configuration. So here we want some node categories, or CMR, it's some instance category in Amazon. It's nice instance. We don't want T or thing like that, or GPU instance, etc. And you can specify the architecture, the operating system you want. So Linux, nothing to tell there. And here you can see our TTL configuration. So that's in seconds. It should be 7 days. It should be 7 days. It's staged, so it's 7 days. And here you will specify the node template you want to use. So here it will be also the default, so that's the default node template. And you can have, the workflows can define a specific provisioner instead if you need. So here that's the node template, so the same, it's the default. You can specify here, it's more the system configuration of the node. So here we define the disk. We want a bigger disk because, or you will have issues. You can specify how it will connect to the security group, to the subnets. So here it will discover then with some labels, maybe more some tags, and with these tags it will discover the good ID, etc. And also you can run some user data. So here just some configuration we need for registry to be able to modify the sysctl net sysctl parameter. So spoiler alert, we're using HAProxy as an application load balancer. So if you remember the diagram, so that's there. So just behind our public load balancer. Public load balancer are network load balancer. It's going to HEpoxy. It's layer 4 to layer 7 load balancers for HEpoxy. It auto-scale depending the request. We got 1 pod per node, and the node are identical because to allow to scale them easily, we know that with this type of node, we can have a certain amount of requests. And we got some protections or DDoS protection. We can block the countries, and also some rate limiting. So that's the internals. So nothing too fancy. So this part on the left side is not managed. I don't think, we don't see it well, but I will describe some parts. So here that it's not managed inside Kubernetes. It's created outside. And we will tag the HEpoxy pod to it, register to it using AWS load balancer controller. So for that, all the HEpoxy pod will be seen as backend of the network load balancer. We will scale the deployment with something called KIDA. It will scale the number of replica, and by scaling the number of replica, Carpenter will scale the number of nodes. And behind, we got all our application that are the backend of HEpoxy. And this configuration is the same for each HEpoxy. We got a lot of different groups depending on the traffic. And we got also some color group, I would say. So the scaling is done with something called KIDA. It's the same. We want more information, kida.sh. Everything is there. We are using KIDA because we can have more way of scaling the replica instead of the basic HPS or horizontal pole autoscaler of Kubernetes. By default, the HPA can scale only on CPU and memory, and with KIDA, we got other scalers. You can scale with a queue, PubSub, RabbitMQ, Redis, a lot of things you can check on their website. And for us, we're using the Prometheus scaler, so we can scale depending on query or to Prometheus, so with our internal metrics. So that's why we went to KIDA. So as an example, it's using also a Kubernetes resource that is called a scale object that got as a target a deployment. And we got our specific query, so we do a sum of all our requests. KIDA will divide by the number of pods, and if, depending the threshold, it will scale up or down the number of replica. Yeah, you can specify the max replica, minimum replica. And here it's some advanced configuration. So for us, it's just to not scale too often, because we got traffic, we don't want to close connection to registry. So that's why we put this configuration. And as an example, here that's the specific provisioner for HEpoxy. So Carpenter, so to scale the node, the HEpoxy node. So we got a specific name, we're using a specific instance, so that's the stage instance, it's a bigger one in prod. And we got some taint to be certain that it's only HEpoxy running this provisioner and this node. And that's all for that. So we got some, I think you know that we got some pool rate limiting in place. So it's done inside HEpoxy. So for that, we got some scripts that will authentify the user. So if you are a login user or not, your plan, etc. It compares with that. It will know the limits you can have. You're using the HEpoxy stick tables to track all the requests. So all the requests you are doing to registry, we track them to know the number of requests you are doing. If you reach the limits, you exceed the limits, you will answer an error. And the long-term plan is to move out. HEpoxy is not something that you should do inside a load balancer. And it's to use some consumption-based limits instead of just a count of your request. That is not really nice. And for more information, we got a lot of information inside our documentation. Go for it. And lastly, for HEpoxy, we got some blue-green deployments. So that means for each group, we got some color group, I will say. So it's behind some weighted DNS records. So it's in as a backend. So here, all the traffic go to the blue group instead of the green one. That allows us to test configuration, to do upgrade, etc., without impacting users. And if issue, we can do an easy react. So as an example, upgrading the green group, no traffic there, so no impacts. And after moving to green, slowly checking the metrics if everything is fine. And yeah, reaching all the traffic go to green. If it's still fine, we can remove blue if needed. And like that, we got no issue doing our test or our upgrade. We do some logins inside our infrastructure. I mean, yeah, like everyone. So we are using some basic things of Fluentd that's sending things to Fluentd as a collector and after to something called Loki from Grafana. We got 2 weeks of retention with Loki, but months or years for everything, for the logs inside the buckets, because they are for security reason and yeah, compliance and things like that. What can I say except that, yeah, and we got something specific for HEPoxy because of the access log. We got 50,000 requests per second, so that means 50,000 log lines per second. So this is a lot, and it's not possible with Loki to do aggregation or things like that, or yeah, it's not possible, it's not working. So for that, we're using something called Athena on Amazon, yeah, and like that, we can aggregate information and have some sort of metrics regarding the access log. Yeah, and yeah, I think I can say more on that. No, I think that's all. Yeah, we got also something called Vector. It's doing the same things that Fluentd, but yeah, a little better for some use case. And here's the use case if we got logs sent to a S3 bucket, it's better to use Vector to extract them and send them to Loki and other things. So all these pipelines are not the best, but it's working fine. So we're keeping them, and maybe at some point really improve them, but yeah, for now it's working fine. After the logging, we got also some monitoring because we need to check that everything is working fine. So for that, first we extract some metrics. So with something I think you know about it, Prometheus, we got a lot of exporters and also our application. So Prometheus will pull the metrics from this exporter and this application and send them to Cortex. We're moving to something called open telemetry kind of thing. So yeah, here it's how it is currently with some open telemetry collector, but you can remove it if you need. It just that for us, after that, we can have different systems and Cortex and all, but yeah. And for Cortex, so the alerts are configured inside Cortex because it's where all the metrics are available. For that, it's using a component called the ruler, and ruler will send the alerts to Alert Manager, and Alert Manager to some external service or Slack and PagerDuty for us. We got 1 month retention period for our metrics. We are looking for having more retention. And for Prometheus, we're keeping only 1 or 2 days because we only need that to, yeah, if there is an issue, to send them to Cortex and have the time to fix it. We got also some tracing in place with Tempo. I mean, it's quite, yeah, not a lot of things to say, just the application sending to Tempo, and that's all. And for all of that, logging, metrics, and also traces, we're using Grafana as a UI. And after that, we got metrics, but we got also on-call. So yeah, that's the on-call in place for all hub and all services on Docker. So like I said, yeah, we got Alert Manager that will send things to PagerDuty. So we are paged by PagerDuty. Here, that's a map of all the Docker employee location in the engineering group. So you can see that we are split between America and Europe. That allows us to have 12-hour shifts. So when you are on call, you are not on call during the night. So that's nice. And how on-call works is that it's a first-level answer. The person on call will check the alerts, try to fix it with some runbooks, and communicate with our user if there is issues, or in our repository feedback, or directly to our status page. So if you see something weird and you're wondering if there is an issue on Docker, go to dockerstatus.com. And for the on-call, yeah, if the runbook is not fixing the issue, it's possible to escalate to other team with a manager on call, etc. So yes, certainly some colleagues. So now, yeah, it's in America. So some colleagues in America that is on call, but currently no issues. And let's finish with some CI/CD stuff. So at CI/CD, we are using primarily GitHub Action, and we moved to public runner thanks to the GitHub or IDC. It's just that with GitHub or IDC, we don't need to share credential between GitHub and Amazon. So if we need to access some role or some resource on Amazon, we can with that without any credential. We are using Terraform. So for example, the load balancer or anything, it was configured with Terraform. And we're using GitHub Action to do the Terraform plan inside the pull request, and afterwards it merge, it will deploy, it will create the Terraform apply, and you will have your change. We're using some Golang library called TerraTest to allow to do all of that, and just that it allows us more option, and we don't have with that, we only got, I will say, a big Golang program instead of having a bunch of bash scripts inside the GitHub Action. It is not really nice to debug. And for Kubernetes things, so here it was much for cloud resources. For Kubernetes things, we are using something called Argo CD. It's some GitHubs in place. So yeah, it's just that it will check some, yeah, that's an example. We got some, we say some application. It will check some repository and some path, and it will deploy what is in play, what is present inside this repo. So it could be some manifest file or directly some Helm charts. So it's possible to target the head. It's what we do in stage. In stage, we want directly the latest version. And for example, for prod, we'll have some tags. We're using tags to deploy after some tests. So after stage is fine, we will take the tags that was creating and deploy it after in prod. Also some word on the CI/CD in place for Docker Desktop, because yeah, that's a big part of our CI/CD. So currently we are moving to GitHub Action also, but it's a lot of work. It's kind of difficult because we need virtual, with this node with virtualization and a desktop operating system. It's not something that you can find easily. So we are using Packer to create images, Terraform to manage this node group. Here we don't have a solution without node groups. And for Windows and Linux, for now it's Azure. It's mainly also because they got some image available for Windows directly, some desktop image available. For Mac, we're currently doing it manually. It's quite painful, but we are planning and checking how to make it with some cloud provider. And it's a lot of nodes. I think you can see Docker Desktop and a lot of nodes and something quite critical. And yes, to finish, there was still this slide. So for the future of all the infrastructure, what we are planning to do is to split more the resources in more AWS accounts. So we are still mainly on AWS and create more AKS cluster. I like that to divide everything, and it's much easier if there is an issue or if you need to do upgrade or things like that. Some things that we want to do, and we are working on it, it's to have blue-green AKS cluster. So like HA proxy. So instead of doing the upgrades that are painful, is to create a new EKS cluster with all your application on it, and after migrate the traffic to this new EKS cluster. So yeah, we are constantly improving our infrastructure. We try, normally we don't do any impact, but sometimes, yeah, shit happens. And we are supporting new products. You could see on the keynotes, yeah, Docker Scouts, we got the build next and things like that. And what we want for all of that is to propose some platform API for all this team to deploy their new services. And also, we are certainly recruiting, so don't hesitate to check on docker.com careers. And if you want to join maybe the platform team, is there something available? I don't know, but I'm checking my boss, but but yeah, and I think that's all for me. So thanks for joining this session. And if you got any questions, we got still some time, so don't hesitate. But I don't think we got a mic, but yeah, okay. Some questions there, thanks. Sorry, can you? Yeah.
How you mentioned rate limiting for HA proxy in Kubernetes. How is rate limiting handled in Cloudflare?
You mean Cloudflare?
The rate limiting, is that different? Does everything route to the Kubernetes cluster and then out to Cloudflare?
You will first, the first requests are always done through HA proxy before checking the blobs of the images. All the blobs of the images, it will go Cloudflare or directly on S3. But first, you will make a request. I think, yeah. Let me go back. It will be easier with some diagram. It's too far. Too far. Yeah, but on registry, yeah, this part, so it's behind HA proxy. So you always need to go there first before going to the second part that will check I will say the blobs, so the data of the images. So because you're going first to there, we will see it on HA proxy, and you can say, okay, we will block you or not. Yeah,
so HA proxy for rate limiting, and if it goes to Cloudflare, the workers just for routing to one of their...
Yeah, Cloudflare just a routing, depending where you are, we will say, okay, go to Cloudflare to have the data, or go to S3, and that's all. But we already know if you got the permission or you're not rate limited by that. But yeah, not rate limited in Cloudflare.
Cool. And I work on the EKS and the Carpenter team. If there's one request that you would have that you'd want to be better about how you manage Kubernetes now, is there anything you can think of?
I mean, some requests. That we can talk maybe later, but I don't. Yeah, maybe better upgrade, but because we will do Belorgey in EKS clusters, yeah, we can talk maybe later. Yeah, thanks.
I understand the need for custom Lua scripts for rate limiting. Is there something that led you to need that specific, like, customized Lua script at that level, at the HA proxy level? And is there any plans to improve that, to move it somewhere else?
Yeah, there's some plans. Yeah, for now, I will go to the. Where is it? Yeah, I don't know. On my slide. For now, we did it. It's also because we need a solution and nothing was in place, so we were checking and it was possible with HA proxy. But it's not nice because it's the number of requests, and normally what we want is, depending the data you are doing, it's what it's costing us more money, because yeah, you can see the amount of data we got. But yeah, we are checking and planning to move that outside HA proxy, so outside the load balancer, and have some dedicated application that will check all of that, and maybe check the size of your image you are pulling and say, yeah, it's more than, I don't know, 100 gigabytes. You say, oh, okay, well, we'll limit you and maybe ask you some money instead, like, I don't know, like any consumption-based things you can have on internet, etc. Okay.
So I have a question about when you configure the Carpenter provisioners, you set the TTL seconds until expired, right? Like at the bottom part.
Yeah.
And I wonder, like, what does that do? Like, why did you set TTL seconds until expired?
Yeah, what we'll do so is that in second, I think it's 7 days. So Carpenter I don't know in details, but it's keeping the time from the time the node was quitting, is keeping the number of seconds, or the age of the node. The age is what's a better word. So, and after reaching the number, what it will do, it will remove the node. So after the pods are inside the node, it will be seen as pending nodes, pending pods, sorry. And it will say, okay, I need to spawn a new node. And by spawning a new node, like I said, it will be a node with the latest EKS image. And for us, it will do all the upgrade we need. So also for security, it's a lot of time when you want some security features, you don't want your nodes to be present for too much long time. So with that, it will allow you to say, okay, I'm pretty sure that my nodes won't stay there for years, and have maybe some issues after sometimes, and it's quite helpful. But maybe the AWS guy below can help you. Other question?
I noticed there, sorry, that you have consolidation turned on for Carpenter. Is that actually on in your deployments, and has that been working well?
What do you mean?
Consolidation for Carpenter.
Yes.
It makes the cluster smaller if it's not being used. And how long have you had that turned on, and how's that been working for you?
It's turned on only in stage, because we try not to move too much in prod, but in stages, also to test things, we say, okay, let's do consolidation, and it's working fine. I mean, the only issue we got with Carpenter, it's more certainly due to Amazon, is we try to use, here you can have on-demand node instance or Spot instance, and we test with Spot, but a lot of time we got issues when an instance could be seen inside our cluster, but it was a dead instance. And even reaching to Amazon support, after a long time, they say, okay, there were issues when it was spawned. We don't know why, but yeah. So we remove it for Spot. But I mean, the consolidation, we got no issue in stage. It's working fine for now, but maybe at some point we will test in prod, but we will see. Maybe after more time, but yeah. Other question? Oh.
Just quick, on Akeda, you were using Keda. What triggers do you use for that to scale?
For Kida, normally it's only, I can find, no, I can't find the slide. I can't find the slide. For Kida, it's just because we want to scale with a Prometheus query. And because we want to scale with a number of HTTP requests. It's not something you can do. Maybe now it's possible, but I don't think with basic HPA on Kubernetes. Normally, by default, you can do only CPU and memory, and because it's not something quite useful for a load balancer. And also, we are using Kida, so for example, with vector for the logs, we're using Keda to check if there is some message inside the queue. And that means if there is a message inside the queue, that's a log line, and try to spawn some vector pod and process this message. So that's also quite useful. Something, if you didn't know about it, check Kida. It's also, it's working fine and quite nice. Thanks. No other question? Okay. Thanks, everyone. Have a nice day.